and I can check where it intercepts, the curve intercepts. So we know that now we have the expression y is equal to m v0 plus b, where m is the slope. This was 1.66, and there's an arrow here that's very small, and b is equal to minus 4.42. So when y is equal to 0, I know the point here where the curve intercepts the x-axis, and I will be able to calculate or estimate the activation voltage. So in this case, I just need to replace here. So that will be right now this is a current, so I will have to convert later on to voltage, or I can do directly. I can change this to voltage, and I'll have a different graph. So if I select the range again, so if I select this range, I have it directly in voltage. So this was in current, and now I have directly in voltage. So in the voltage is y is equal to m v0 plus b, where m is equal to 0.861 and b is equal to minus 2.3. Now when y is equal to 0, the activation voltage v0 is the quantity I want to measure. That means that 0 is equal to 0.861 v0 plus b, which is minus 2.3, and that means that 0.861 v0 is equal to 2.3, or v0 v0 is 2.3 divided by 0.61, and if I go to the calculator, I get 2.3 divided by 0.861, and that will be approximately 2.67 volts. So that's the activation voltage. For the LED that you have in the lab, the activation voltage is more or less the same. All right, so you calculate the activation voltage for each LED. So you have to connect the probe to each LED and close the circuit here, just closing with the switch. All right, now we want to send the signals to this phototransistor. So there is a power supply, a 6 volts power supply that I can connect right here. And then I want to measure between these two terminals. So let's connect now to channel B. And then I can connect the high voltage here, the lower voltage here. And then I have to connect the fiber there. All right, so now if I go back to Pascal, I can select channel B. So this is the voltage sensor. And then I can connect right here, voltage sensor. Let's see if I plot as a function of the of the output voltage. Now let me create a new graph. So you see that it's very noisy here, and this is likely a problem with the ground, because this ground is not the same as this one. So we'll do this, we'll connect